Dear students, this is a short video to take you down through the solution for the December 2019 paper, Trojan Limited. This was the question that we started in class on Tuesday of last week and that you were to finish for homework. Trojan Limited is a Waterford-based company specialising in giftware and Christmas decorations. The company exports to the UK and is considering purchasing a new 3D printer costing £5,000 payable immediately. So there is your initial investment. In order to manufacture the personalised 3D gifts and decorations, it is expected that the machine will have a useful life of 5 years and a residual value of £20,000. Okay, so that £20,000 is your scrap value. The company has paid a local market research firm of £20,000 to ascertain the level of demand for the product. So that's a sunk cost. Okay, so regardless of whether we take on the project or not, the organisation has or will incur the £20,000. The market research firm has reported that the sales will depend on the state of the global economy and the strength of the post-Brexit trade deals. They have just prepared the sales forecasts in units. Okay, so here we have the units for year 1 to 5. Okay, so this is how many units we expect to sell over the lifetime of the project. The product is expected to sell for €32 per unit and the variable production costs are €8 per unit. Okay, so let's do our first calculation. Okay, so our first calculation is determining what our cash flows are. Okay, so we have year 1 to 5 and we're going to include our sales units. So 2670, 2820, 2950, 3500 and then 3875. Okay, so that's coming directly from the question. The contribution then is the selling price. So the selling price minus the variable price equals your contribution. Okay, so if we look back at the question, we can see that the selling price is €32 and the variable costs are €8. Okay, so 32 minus 8 is your contribution. Okay, so if we just go up here, we can see that this particular product has a contribution of 24. So we're going to put in 24 in each of the years. Okay, we can then calculate what our cash flow is. Our cash flow is simply the sales units multiplied by the contribution. So the cash flow in year 1 is 64,080 and so on and so forth. Okay, again, nothing new there. Okay, so we then have the starting point in order to be able to calculate our net present value. Remember, for the net present value calculation, you'll always start off with year 0. So the first thing we're going to input here is the initial investment. And when we look back at the question at the very top, okay, the initial investment was the payment that we're going to make for the machines, 50,000. So we're going to include minus 50,000 in there. Okay. We're then going to include the scrap value. Okay, so after the 5-year period, it's expected the scrap value will be 20,000. Okay, so that's 20,000 is going out in year 5. The company has paid a local market research firm 20,000. Okay, so again, we've identified that as a sunk cost, so we will not be including that. The next thing we can include in our calculation is the cash flows. Okay, so our cash flows are as calculated above. So year 1, the 64,080 and so on and so forth. So we're just dragging those down. Again, you may have some of these, and if you do, just mark them so that you can identify where it went wrong for you. The next thing then we're going to have a look at is the additional costs or the relevant costs that are included in the question. So the company will need to hire additional staff at a cost of £23,000 per annum for the first 3 years, increasing by 10% in year 4 and a further 15% in year 5. Okay, so we're going to put in the 23,000 in the first 3 years first and foremost. So we'll say staff costs. Okay, so we have 23,000 in year 1, 2 and 3. That 23,000 is going to increase by 10%. So we're going to say 23,000 and we're just going to multiply it by 1.10. Okay, and then in year 5 it's 15%. Okay, so 15% is year 4, and again we're going to multiply it by 1.15. Okay, so I'm just going to take out these totals automatically auto-populating here on me. The company currently pays $45,000 per annum for the insurance. It's expected that the insurance will increase by $75,000. Okay, so when we're calculating the net present value, we are only concerned with the relevant costs. Okay, so the additional costs associated with taking on the particular project. So for the insurance costs, we're only concerned with the $30,000. Okay, so we'll put insurance costs. And we're going to put in, we might just put minuses here, okay, just not to confuse the thing, because these are outflows for this particular business. Okay, so here we're going to include minus 30,000. Okay, and we're just going to feed that all of the way across. Okay, and if we just look at the last bullet point, then if the company goes ahead, the company will have to cease its production to another product, which will generate a net cash flow of $7,500. So that's known as an opportunity cost. So basically, by taking up this project, the company will no longer be able to avail or to provide that product or the service to its existing customer base. Okay, so we include that in there at minus 7,500. Okay, so we've included everything we need here for our cash flows. So we're simply going to sum up our various columns across year 1 to 5. Okay. And that is a lot of the hard work done. Okay, so if we just go back to the question, okay, it tells us that the cost of capital is 8%. So in order to determine what our discount factors or our discount rates are going to be, we go to 8%. We start off in year 1 and we work our way down. Okay, so if we just go back here, you can see that these figures I've automatically just populated in there for you ahead of this video. Okay, just to ensure that it's nice and short for you. Okay, again, at this stage you should know how to use the discount tables. If it's a case that you still don't know how to use the discount tables, over the course of the next week and a half in class, can you please stop me and I can show you again. So to calculate the net present value, then we simply take the undiscounted cash flows and we multiply it then by the discount factor. Okay, so if we just pull that across again, you can see where those figures are coming from. So for the 3,315, it's the 3,580 multiplied by the 0.928. That then gives us a net present value of 14,830 euros. Okay. So, moving on then, if we look at the requirement of the question, okay, so it's asked us to calculate the net present value and the internal rate of return. Okay, so for the internal rate of return, remember that you need a positive and you need a negative net present value calculation. So the 8% is already giving us a positive. Okay, so what I've done here is I've actually discounted our cash flows from above. So these guys here, pull them down again, and I'm discounting at a rate of 20%. So remember, when this is positive, when you have a positive net present value, you discount at a higher rate. So we'll be discounting at a higher rate other than 8%. Okay, so the NPV at 20% turns out to be 7,198. So here we have all of the required components to calculate the internal rate of return, being a discount factor that gives a positive and a discount factor that gives a negative. So here is our IRR formula. Again, that will be given to you on the day of the exam. Okay, so the capital A is a discount factor, the smaller discount factor, so it's 8 plus, in brackets, small a, which is the NPV of the smaller discount rate, so the 14,830 that we've calculated up here, divide by small a, which is we've already discussed, minus the small b. Okay, so the small b is a discount or the net present value associated with the bigger discount rate. So here it's minus 7,198, okay, but two minuses make a plus, okay. You then multiply that by b minus a. So b is the bigger discount rate, so the 20 minus the smaller discount rate of 8. So again, you need to do this in a couple of steps, okay. So 8 will remain the same. You do this section first, okay. So what I would recommend, and again from going around and helping you with this last Tuesday, I would recommend you do this section first, you get your answer, and then you take the 14,830 and divide by the answer. You then multiply that by that answer, which is 0.672, by 12, which is the 20 minus the 8. When you have that answer, you then plus the 8, okay. So it's bringing you back to algebra, way back to primary school. The IRR then for this particular project is 16.07%. So that is the discount rate where the net present value will equal to 0, where the project will break even. Okay, and that is effectively the solution for the December 2019 paper. I hope you found this solution useful. If you have any further questions on reviewing this solution, please do let me know and I can discuss them with you. Thank you.